Today we're going to talk about something wild. A moment of impossible physics, totally frozen in time. It's a story all about extreme speed, incredible pressure, and intense heat that, somehow, ends with two different things becoming one. Let's get into it.
So, here's a question for you. What do you think happens when two pieces of metal fired directly at each other actually meet in the middle of their flight? You probably imagine them just shattering into a million tiny pieces, right? Or maybe ricocheting off in a shower of sparks. But what if the answer was something much, much weirder?
Yeah, that's right. Under this incredibly rare set of circumstances, they don't break apart. They don't bounce off each other. They literally fuse into a single, seamless piece of metal. And that leads us to this fascinating physical puzzle, an object that, by all conventional logic, really shouldn't even exist.
I mean, really think about it for a second. These artifacts, which have been found on battlefields from the American Civil War all the way to Gallipoli, are basically the remnants of a 1 in a billion chance. We're talking two separate projectiles, fired from opposite sides, meeting with such perfect violent symmetry that they just merge into a single, twisted form. So the big question is, how on earth is this even possible? Let's break down the anatomy of this absolutely extraordinary collision to really get the science behind it. Okay, so in 99.999% of cases, you're going to get a typical impact. The lead is brittle enough, it would just fragment. It's over. But in that tiny, tiny fraction of a percent, something absolutely incredible happens. You get a fusion impact, where the physics of the collision just completely changes the entire outcome.
Now, for this fusion to happen, the universe needs to thread a very, very small needle. I mean, everything has to be perfect. The bullets have to be moving at high, almost identical speeds, but in opposite directions. The alignment, it has to be perfectly head-on, not some glancing blow. And crucially, they need to be made of the same soft material, usually lead, which is way more likely to deform than to shatter.
When that perfect alignment of conditions happens, it creates an instant of almost unimaginable energy, all concentrated into one tiny, tiny space.
We're talking about a combined impact velocity of over 1,500 miles per hour. Just to put that in perspective, that's more than twice the speed of sound. All of that forward momentum has to go somewhere, and it has to do it in a fraction of a millisecond.
And that sudden stop, well, it generates an unbelievable amount of pressure, measured in something called gigapascals. And to give you an idea of what that means, 1 gigapascal is 10 times the pressure at the deepest point in the entire ocean. It's a force so immense, it can literally reshape solid metal in an instant. And all that kinetic energy from the speed, it can't just disappear, right? Physics says it has to be conserved. So it instantly transforms into thermal energy. In other words, extreme heat. The surface of the lead can spike to over 900 degrees Fahrenheit, basically approaching its melting point in the blink of an eye.
And this is the critical moment of transformation. For just a fleeting instant, the intense heat and pressure make the solid lead behave almost like a soft, pliable liquid, even though it hasn't actually fully melted. It becomes malleable, just like two pieces of clay being slammed together.
Okay, so we've got the ingredients: extreme speed, insane pressure, and incredible heat. But what's the actual scientific mechanism here? What's the glue that binds these two pieces of metal together for good?
And this really is the core of the puzzle, isn't it? We see them welded together, but they haven't turned into a puddle of molten lead. How can a solid thing actually bond to another solid thing?
Well, the answer is a process called forge welding. It's actually an ancient blacksmithing technique, but it's happening here in maybe 1,000th of a second. The key is that it's a solid-state process. The metal gets hot and soft enough for the atoms to kind of move around and mingle, but it never fully liquefies.
Let's walk right through it. So first, the immense pressure of the impact flattens and mashes the two surfaces together, getting rid of any gap between them. Second, that kinetic energy converts to heat, which gets the atoms at the surface all excited. And then third, with enough heat and pressure, the atoms from one bullet literally jump across the boundary and form new, strong metallic bonds with the atoms of the other bullet.
So the really crucial point here is that this isn't just two things stuck together like glue. On a microscopic, atomic level, the crystalline structure of one bullet actually grows into and merges with the structure of the other. They are no longer two separate objects. They have become one single, continuous piece of metal.
So, while these objects are often seen in museums as, historical novelties or curiosities, they're actually something much, much more profound.
And here's why this really matters. Each of these fused bullets is basically a perfect accidental experiment. It's a physical record of forge welding happening at speeds and pressures that are incredibly difficult and expensive to replicate in a controlled lab setting. This gives material scientists invaluable data on how soft metals behave under extreme stress, which can then inform everything from designing safer cars to developing new alloys for aerospace. It's a testament to some truly extraordinary physics hiding in plain sight.
And it really makes you wonder, doesn't it? If a chaotic battlefield can accidentally create a perfect physics demonstration, what other incredible scientific principles are playing out all around us every single day, just waiting for us to notice?